As we talk about some of these measurements that we can do, I want you to understand a couple of principles that explains why using Beer meters and making measurements makes sense. Now, when we teach grounding, we have three principles that we repeat over and over and over, and we use those principles as a method of ensuring that the grounding is going to work, understanding what the risks are, and understanding where those grounds need to be put. So the first principle is that current flows in every available path inversely proportional to the resistance of the path. So if I have a current supply and I have anything connected to that path, that current is going to divide and it's going to flow through every available path. It's not just going one way. When I ground a truck or ground a substation, we think that that voltage is going and that current's going to go through that grounding path into the earth. But it's not just going into the earth. It's going to go on every connected pathway that's out there. The second rule is that if I insert a resistance in a current carrying grounded conductor, a voltage is going to appear across that resistance. So you see the graphic up here where I've got a ground cable connected to a conductor and then connected to earth. The only true zero voltage in our industry is the earth itself. Anything connected to the earth is going to have a voltage associated with it that's going to be above zero, and it's going to be proportional to the resistance of that pathway and the amount of current that flows through it. So you see here in the graphic, we have a pathway from a bus going to ground, and the meter shows that there's a very low voltage on it. That occurs every time current flows across our grounded pathway. In fact, this is not a grounding lesson, but when we put a bonding jumper up around the worker, that bonding jumper has resistance. When current flows through it, a voltage is going to develop across that bonding jumper, and that's the voltage that the lineman will sense or will be exposed to. So bonding that worker in keeps that voltage down to around 3, 4, 5, 8, 10 volts, well below the threshold of risk, which is rule number 3. When I put that bonding jumper up, if I keep the voltage below 50 volts, that voltage cannot break the resistance of my skin. If voltage can't break my skin, current can't flow, can't get hurt. So now it doesn't matter if it's 50 milliamps or 50 amps or 500 amps or 5,000 amps. If I keep that voltage below that threshold where it can't break the resistance of my skin, I can't be hurt.